In this video, I will show you how to take a vector that you're given and find a new vector that goes in the same direction but has a new magnitude, whatever magnitude you want. Now, the magnitude and direction r and theta. So whenever you see r, I'm talking about the magnitude, and if you see theta, I'm talking about the direction. And when I talk about the direction of a vector, all right, say this is my vector. The direction I'm talking about is measured from the positive x-axis like this. So this angle is the direction. So if you know the magnitude that you want, in this case 6, and if you know the direction that you want, you can write a vector by doing r cosine theta and r sine theta. So we will just use this little formula to find a vector that has this direction and this magnitude, whatever magnitude we want. So that means all we have to do is find theta. All right, we're given r, in this case 6, so all we have to do is find theta. So how do we find the direction? Just make a diagram. So with the horizontal component of -3 and a vertical component of 6, that means we are left and up. This vector is in the second quadrant if we draw it in standard position. So let's think about the vertical component and the horizontal component. The horizontal component is -3, the vertical component is 6. So we should be able to find this reference angle by doing the inverse tangent. So the tangent of this reference angle would equal 6 over -3. So the reference angle should equal the inverse tangent of 6 over, well, let's go ahead and just say 2. Okay, notice I'm going to go ahead and ignore the negative sign because all I really want is the positive value of r. So I'm just going to think about 6 over 3, and which is 2. So if you put this in your calculator, that is 63.43. Okay, so that's the reference angle. Now the direction is this angle theta, so we can find theta by doing 180 minus 63.43. Okay, so theta turns out to be 116.57 degrees. So now we have both of the things we need. We have the magnitude, which is 6, and now we have the direction. So we can use this little formula to find the vector that we're looking for. So we will just do 6 cosine 116.57 and 6 sine 116.57. And put that in your calculator. So the horizontal component is -2.7. and the vertical component is 5.4. And that's it. This would be a vector that has magnitude 6 and direction of 116.57, which is the same as the direction of the original vector. All right, go ahead and pause the video and try to do problem number 2 by yourself. The horizontal component is +4, the vertical component is -7, so that is right and down. That puts us in the fourth quadrant. All right, so here's my horizontal component, here's my vertical component, this puts me in a position to find the reference angle R, because the tangent of R will equal 7/4. I'm ignoring the negative sign because I just want the positive value of R, so I'm not putting the negative sign. So angle R should equal the inverse tangent of 7/4. Calculator. So 60.26. degrees. Now, the actual direction has to be measured from the positive x-axis like this. We call this theta. So we should be able to find theta by doing 360 minus r. So the direction is 299.74 degrees. So that's the direction of vector W. So we want a new vector that has the same direction but with a magnitude of 8. So again, we can find this vector by doing r cosine theta, r sine theta, where r is the magnitude that we want of 8 and theta is the direction that we want, 299.74. So here we go, 8 cosine 299.74 and 8 sine 299.74. And just put that in your calculator. So the horizontal component is 3.968. This would round to 4.0 if I round to the nearest tenth. So 4.0 and negative 6.9. And that's it. Hey guys, that's going to do it for this video. Go ahead and click over here to watch the next video, and click over here to subscribe. That way you'll get every new video delivered right to your home screen.